Alright, here we are again. We're working on lesson 7.2 right now. This lesson is about the converse of the Pythagorean Theorem. Okay, so Pythagorean Theorem, in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So today we're going to look at it backwards. Converse, we're going to start with knowing all about the legs, and we're going to figure out whether or not we have a right triangle. So let's just go back to an example of just regular Pythagorean Theorem. So right now we have 6, we have 8, and we have x. So we know that a squared plus b squared equals c squared if we have a right triangle, which we do here. A and b are the legs, c is the hypotenuse, so we're going to go ahead and do this work here, and then we're going to talk about it a little bit. 6 squared plus 8 squared equals x squared. 6 squared is 36, 8 squared is 64, 100 equals x squared, and we take the square root of both sides, and x equals 10 units. So we know that if this is actually a right triangle, which we know up here because of this that it is, then x would have to be 10. Now, you might have noticed that this is a Pythagorean triple, 6, 8, 10. We could take 3, 4, and 5 and double all of those. Hopefully you remember 3, 4, 5 from lesson 7.1. If not, you're going to need to go back and memorize those a little bit more. So 3, 4, 5 times 2, doubling everything, would give us 6, 8, 10 as well. Now what the converse says is it says we don't really know we have a right angle here. So we kind of cover that up. But if this side is 10, then it would make this work in the Pythagorean theorem. 6 squared plus 8 squared does equal 10 squared. So therefore, it has to be a right triangle. So it just does things backwards. All right? We're familiar with that with converses. So if a squared plus b squared equals c squared, then our triangle is a right triangle. Now a and b have to be the shorter sides, and c has to be the longest side. And if this does work, we get a right triangle, then c becomes the hypotenuse. Okay, so make sure that when you set this up, when you're doing these checking to see if something's a right triangle or not, make sure you always put the shortest sides for a and b. The order of those two does not really matter. And make sure that you put c on the as the longest side. All right, so let's take a look here at an example. So do 16, 30, and 34 form a right triangle. So what we're going to do is we're going to put them into the a and the b and the c, and we're going to do the math. So 16 squared plus 30 squared. I'm not going to put equals because I don't really know if they're equals. That's what we're checking. So I'm just going to put a big question mark here. 34 squared. All right, so I'm going to go ahead and let you do that real quick. All right, so go ahead and do that math, and then I'll do it right after you, and let's see if we actually get an equal sign there. Alright, hopefully you're done by now. So 16 squared, 256. 30 squared is 900. 34 squared is 1,156. We add here, we get 1,156, which does equal 1,156. So yes, we have a right triangle. Alright, so that's how we're going to go through this process. Now let's come over here. Do 3 root 5, 6, and 3 form a right triangle. We have a little problem here. With this 3 root 5, we don't really know whether it's bigger or smaller than 6. Okay, so I'm not really sure if this is C or if this is C. Obviously 3 isn't C because it's definitely smaller than 6. So at this point, I'm going to go ahead and use my calculator. I have a pretty good idea of what 3 root 5 is. But you guys may not, and I'm going to let you use your calculators to do that. So I'll show you what it looks like here. So we got 3 root 5, so 3, let me clear out all that other stuff. Alright, so 3 square root of 5. This is the newer operating system. When you get that arrow there underneath the root, you need to hit your right arrow button right here. Alright, that'll take you out from underneath the root. Alright. And if you need to do anything else, then you can do that, but we're just hit squared. Alright, so that gives me 6.708, a bunch of other decimals. I don't really care about that as a whole lot. All I'm going to do is write down 6.7. Okay, it's rounded off a little bit. Now, I'm never going to use that decimal again. I just use it to check which one is A, which one is B, and which one is C. So since 6.7 is the biggest, this is going to be my C. These are my A and my B. So now let's set this up. A squared plus B squared, big old question mark. I'm not really sure if they're equal. And then C squared. I'm not using the 6.7. We're going to use 3 root 5. And remember, we learned how to do this back in lesson 1. We put it in parentheses, and we do our squaring. So 3 squared is 9. 6 squared is 36. And then remember, we square these individually. So 3 squared, root 5 squared, 9 times 5, and 9 times 5 is 45. 9 plus 36 is 45. And so they are equal. So yes, we do have a right triangle. This is not a Pythagorean triple. Remember, Pythagorean triples, you're not allowed to have decimals or fractions or roots or anything like that. But it's still a set of numbers that does work in the Pythagorean theorem. So you notice we did not use the 6.7. If you actually use the 6.7 here, it wouldn't work. All right, I'll show you that real quick if we use the 6.7. So 3 squared plus 6 squared, big old question mark, 6.7 squared. All right, once again, we know this is 9 and this is 36. 6.7 squared. Use your calculator if you need to. Let's see if I can do it by, let's see, I believe it is 44.89. Double check that real quick. 6.7 squared. Yep, 44.89. Okay. So 45 does not equal 44.89. So you'll see that we have a problem here. We would have thought the answer was no if we had used this, but 6.7 is rounded off. When we use something that's rounded off, this becomes a little bit inaccurate, and that's why we don't want to do this. So if you do this, you're going to get it wrong. All right, so do not use a rounded off decimal in your calculations. All right, let's take a look at another example. Do these numbers form a right triangle? All right, so I'm going to let you go ahead and do that real quick. Once again, give you a little bit of time. I want you to go ahead and try that one. Alright, that should have given you plenty of time, so we're going to go 9 squared plus 10 squared, question mark 15 squared, 81 plus 100, 225. 181 does not equal 225, so no. Does not form a right triangle. Right? Sorry, couldn't see all that work there. There you go. Take a good look at that work. 181 does not equal 225, so no, this is not a right triangle. So the question becomes, well, what kind of triangle is it? All right, so let's take a look at this. All right, so I'm going to draw a real just quick sketch of this. We know that we've got 9 and 10 and 15. All right, now I'm going to backtrack a little bit. I'm going to come back over here, and I'm going to put an X right here for the 15 briefly, just for this explanation. 9 squared plus 10 squared equals X squared. Now this would be true if we had a right triangle. 81 plus 100 equals X squared. 181 equals X squared. Square root. 181 doesn't break down at all, but if we do type it into our calculator, the square root of 181, let's see, that's going to be somewhere around 13.5, maybe a little bit bigger than that, a little bit smaller, okay, 13.45. All right, so X equals 13.45. Now let's go back up here. We know that if this was 13.45, it would be a right triangle. So we're going to use the concept of the hinge theorem now. So let me draw another example of that same triangle with an actual right angle with the square root of 81, which is approximately equal to 13.45. Okay. So comparing these two triangles, let me zoom out a little bit so we can see them at the same time. All right, we have two sets of congruent sides. We have a third side that is not congruent. The bigger third side is across from the bigger included angle. And we know that this angle is 90. So this angle has to be bigger than 90. So therefore, this must form an obtuse triangle. All right? So when we get 181 is less than 225, okay, right back here, instead of putting a not equals, we can put a less than sign, or sometimes they'll end up being a greater than sign. But a less than sign means that we have an obtuse triangle. Okay. All right, so think through that again. We've got 9, 10, 15. We have this one, which is 9, 10, and about 13 and a half. That about 13 and a half leads to a right angle. So a bigger side must lead to a bigger angle than a right angle. So therefore this must be an obtuse angle. So if you get a less than sign in here, it's going to be obtuse. The opposite, if you get a greater than sign here, it's going to be an acute triangle. All right, so we're going to do some examples of that. So what kind of triangle is formed by the following sets of numbers? Sorry, couldn't get that all on the screen at the same time. Let's show that again. This is the question. What kind of triangle is formed by the following sets of numbers? Okay, so we'll start with a pretty easy one, 10, 11, 14. Okay, so A, B, C. All right, always put C for your biggest. A and B you can switch around and it won't matter. 10 squared plus 11 squared, question mark, 14 squared. 100 plus 121. 14 squared is 196. 221 is greater than 196. Okay, so we know it is definitely not a right triangle, so we have to decide if it's obtuse or acute. And the main thing is always focus on the C side of the equation. If C squared is too small, then that means C must have been too small, which means the angle across from C must have been too small. Well, we know that if it was equals, it would be a right angle. So that means that the angle across from C, C was the biggest side, so the angle across from is the biggest angle. The angle across from this was too small to be a right angle. So if it's too small to be a right angle, it must be an acute triangle. Okay? A squared plus B squared greater than C squared gives me an acute triangle. Sometimes that's a little confusing because greater than you think bigger actually leads to a smaller angle. That's why we always focus on the C side of the equation. If C squared is too small, then C is too small, so therefore the angle across from it is too small. The angle is too small to be a right angle, so therefore it's an acute angle, giving us an acute triangle. All right, let's do another one. Got to be careful here. These aren't in order from smallest to biggest like sometimes we have them, so we got to think about which one is A, which one is B, and which one is C. All right, so this is C. A and B, does not matter what order you put them in. I'm going to go ahead and put them in slightly different order of 8.2 squared plus 4.1 squared, big old question mark, 11.7 squared. A lot of times we'll make A the smallest, but it doesn't really matter, so we can go either direction. All right. 4.1 squared, that one's kind of easy, it's 16.81. 8.2 squared is a little harder, let's see, 67.24, I'm going to double check that just to be safe. 8.2 squared, alright, 67.24 plus, alright, 11.7 squared. That was a little more complicated. I'll speed this up, I'm not going to try to do it in my head. 136.89. Okay, we add these two together here, 67.24 plus 16.81, and we get, I'm just typing this into my calculator so I don't make a careless mistake, 84.05, 136.89. This is definitely less than. Okay, always focus on the C side. C squared, too big. Excuse me, which means C, way back here, C was too big. Too big to be a right angle. If it's too big to be a right angle, it must be an obtuse angle, and therefore we have an obtuse triangle. Alright, let's go up here and try this one. Alright, got another problem here. I don't really know how big 2 root 7 and 3 root 7 are. I know 3 root 7 is definitely bigger than 2 root 7. So this can't be C. Alright, but I don't know which one of these is C until I type them in. But I'm gonna type this in just to be safe. We're going to use that later on sometimes as a little bit of a check. So I'm just going to type them both in real quick. So 2 root 7 gives me 5.29. I'm going to go ahead and write that down as 5.29. All right, 3 root 7. .94, and then we have our 6. So now it's pretty easy to tell we've got an A and a B and a C. All right, we are not going to use these decimals though, because if we use decimals, they've been rounded off. They're going to give us inaccurate answers as we finish up. So we're going to use the 2 root 7 and the 3 root 7. So A squared, we put that in parentheses, plus B squared, big old question mark, and 3 root 7 in parentheses squared. Okay, remember how we do these things with the 4 steps? So we're going to keep doing that. Yes, I'm going to make you keep doing it for this lesson as well. And if you don't do it and you don't show your work, you're not going to get credit for it. So keep showing your work. 2 squared, root 7 squared. 4 times 7, 28. 3 squared, root 7 squared, 9 times 7, 63. Okay, 6 squared we know is 36. 28 plus 36 is 64, which is greater than 63, barely, but it's bigger. So we have a non-right triangle. Always focus on the C side. C squared is too small, so therefore C was too small to be a right angle. And if it's too small to be a right angle, it must be an acute angle, so we have an acute triangle. All right, here we go. Last example for this one. Don't just shut it off, because there is something different about this one. Okay, I want you to go ahead and try this one real quick. I'll give you about 2 minutes to do this. I'm not going to wait 2 minutes and just silence on the video though, so pause it, do it, all right, and then we'll restart the video or whatever you need to do. But all right, so get started on that. All right, here we go. Seriously, if you haven't done it, pause the video, do this example, figure out what kind of triangle we have here. All right, now, if you have done it, all right, most of you probably got an answer of obtuse. And if you got an answer of obtuse, you're wrong. So I'm going to show you why you're wrong. Now, it is true that you do get a less than sign in here, but it's still not an obtuse triangle, and I'm going to show you why. All right, so this is probably what most of you did. Most of you probably did 15 squared plus 19 squared, question mark, 36 squared. All right, so 15 squared is 225, 19 squared is 361, and 36 squared is 1,296. 225 plus 361, that gives us 586. 1,296, and obviously that is less than. All right. However, this is not an obtuse triangle. Yes, I know usually this less than concept means obtuse, because C squared is too big, so C is too big. So the angle across from C is too big to be a right angle, so therefore it's obtuse. However, this isn't an obtuse triangle. So I want you to go back up here and look at this. See if you can figure out why this is not an obtuse triangle. Okay, so I want you to think about that for a second. All right, see if you can figure out why 15, 19, and 36 do not form an obtuse triangle. Anyone figured it out yet? Okay, the correct answer is this is not a triangle. These three lengths do not form a triangle. And since they don't form a triangle, they obviously can't form an obtuse triangle. All right, some of you are still probably trying to figure out why it's not a triangle. So think about that. It goes back to something we learned in a previous chapter. Some of you are finally starting to figure it out, okay? Some of you are still wondering, what in the world is Mr. Oates talking about? I don't know why this isn't a triangle. So let's think back to something we learned in a previous chapter. We learned in a previous chapter that the two sides added together must be more than the third side. 15 plus 19 is 34. 34 is not more than 36, so therefore these three segments cannot form a triangle. All right, we learned that in the previous lesson, previous chapter, so hopefully you remember that. If not, this is a good review. Two sides added together must be more than the third side. This does not equal something more than 36, so you know what? We don't need to do this work at all. Okay, you don't even have to do any of that work. All you have to do is say, hey, 15 plus 19 isn't more than 36, so therefore it's not a triangle. All right? So that's how you do this type of problem. It's a little bit of a trick question, but don't be surprised if you see it in your homework or maybe on a quiz or a test. All right? All right, so let's look back at some of these other ones to see why they were not trick questions, because none of the previous ones were. All right, if we look here, we get 10 plus 11, 21. 21 is greater than 14, so this does form a triangle. All right, remember, we always just need to add the smallest two sides together. We don't have to bother adding 10 and 14 together. All right, so 10 plus 11 is 21. 21 is greater than 14. That's definitely a triangle. If we look at this one here, all right, two smallest sides, 8.2 and 4.1. If we add those together, we get 12.3. 12.3 is greater than 11.7, so it is a triangle. Then we do this type of work where we have to actually do the squaring. Okay, up here on this one, this is the reason that I did both decimals here. All right, 5.29 plus 6 is 11.29. 11.29 is greater than 7.94, so this is a triangle. Then we do our work that we did here before. All right, now even if we get something like this, okay, 6, 7, and 13, this is not a triangle because the two smallest sides added together are not more than the third side. All right, if you just add them together and they equal the third side, it's still not going to form a triangle. All right, so if I give you a question like this on quiz, test, homework, something like that, and you have to explain why it is not a triangle, all you do is say that the two smallest sides added together are not more than the third side. And if you say that, that'll be a good reason for why is this not a triangle. All right, now we're going to have a little wrap up here, and we'll finish up the lesson. All right, so here we go. We got three options. If a squared plus b squared equals c squared, we have one thing going on. If a squared plus b squared is greater than c squared, we got another thing going on. And then if a squared plus b squared is less than c squared, we got another thing going on. So let's go back and look at each of these individually. If this is true, keeping in mind that c is always the biggest side that we are dealing with, then here we have a right triangle. That is the converse of the Pythagorean theorem. If a squared plus b squared equals c squared, then we have a right triangle. Okay, let's come over to this one. If a squared plus b squared is greater than c squared, that means c squared is too small, which means c is too small. The angle across from c is too small to be a right angle, and if it's too small to be a right angle, it must be an acute angle. But since c was the biggest, it's still the biggest angle in the triangle, and if the biggest angle in a triangle is an acute angle, then it's an acute triangle. This is a theorem. It doesn't have a name, okay? But it is a theorem. It doesn't have a name, though. All right, last one. If a squared plus b squared is less than c squared. C squared is too big. C is too big. The angle across from c is too big to be a right angle. And if it's too big to be a right angle, it's got to be an obtuse angle. You cannot have more than one obtuse angle in a triangle, but it's an obtuse triangle as long as it's got one. At least remember, not in flat surface, planar, Euclidean geometry. You cannot have more than one obtuse angle. All right, so there we go. Those are the three things you need to do. You need to know how to do. That one, a squared plus b squared equals c squared is a right triangle. A squared plus b squared is greater than c squared gives you an acute triangle. And finally, a squared plus b squared is less than c squared gives you an obtuse triangle. Double check to make sure you have a triangle before you bother doing any of the squaring work. Otherwise, you might be wasting your time. That is the end of lesson 7.2.